There is a planet so close to the Sun that most telescopes on Earth are never even pointed at it. Astronomers avoid it. Casual observers forget it exists. And yet, tucked into the blinding glare of our star, Mercury has been keeping a secret for over 4 billion years. Tonight, we're going to look where almost no one looks. Consider this. Mercury is the closest planet to the Sun, orbiting at an average distance of just 58 million kilometers. It completes that orbit in only 88 Earth days. But here is the detail that unsettles even seasoned scientists. A single day on Mercury, sunrise to sunrise, lasts 176 Earth days. 2 full years pass on that world before the Sun rises even once. Time itself behaves differently there. We tend to imagine Mercury as a simple, dead rock, a scorched leftover from the birth of the solar system. That assumption, as you will see over the course of this documentary, is dangerously incomplete. Beneath its cratered, silent surface lies a structure that violates almost everything early astronomers believed about small planets. And within its shadows, literal shadows, some of which have not seen sunlight in millions of years, something waits that scientists still cannot fully explain. There is a figure who has spent decades studying this planet from the edges of academic silence. We will call him for now only by the name given to him by the very few colleagues who still speak of him, the silenced cosmologist. You will see his outline before you ever hear his full story. And by the end of this film, you may understand exactly why he chose the shadows over the spotlight. Mercury does not ask to be understood. It resists us the way a locked room resists curiosity. But tonight, we begin turning the handle. And once you see what lies inside, you will never again think of that small, silent world as empty. In the next chapter, we uncover the anomaly that once made Isaac Newton's own physics appear to be wrong, and the almost impossible answer that Albert Einstein found waiting in Mercury's orbit. For nearly 200 years, Mercury carried a secret that no mathematician could solve. Its orbit refused to behave. Every planet drifts slightly over time, a slow rotation of its elliptical path called perihelion precession. Astronomers could calculate this drift for every planet in the solar system using Newton's laws of gravity. Every planet except one. Mercury's orbit precessed by an extra 43 arcseconds per century that no equation could account for. 43 arcseconds. A number so small it seems irrelevant, and yet it haunted physicists for generations. Some proposed an invisible planet, nicknamed Vulcan, hiding even closer to the Sun, tugging at Mercury with a gravity no telescope could detect. Search parties of astronomers hunted for it during solar eclipses. They found nothing. Nothing because the answer was never a missing planet. The answer was that gravity itself was not what anyone believed it to be. It was Albert Einstein, in 1915, who finally solved Mercury's riddle. His general theory of relativity proposed that massive objects like the Sun do not simply pull on space, they bend it. Mercury, orbiting closer to that curvature than any other planet, was the one world sensitive enough to reveal the warp in the fabric of the universe itself. When Einstein applied his new equations, the missing 43 arcseconds appeared, precisely on paper. A tiny, stubborn planet had just confirmed one of the greatest theories in the history of science. Try to hold that thought for a moment. A world so small, so overlooked, became the proving ground for the truth about gravity, time, and space. There is something almost poetic in it. The smallest planet forcing humanity's greatest minds to rewrite the rules. It is a cold kind of validation, the way ice confirms the temperature of a room no one dared to enter. Mercury did not explain itself gently, it forced the correction. Somewhere in this story, the silhouette we glimpsed before reappears. Those who study Mercury's anomalies today speak of a man who devoted his career to numbers like these, precise, cold, unforgiving numbers, and who eventually vanished from public scientific life without full explanation. What happened to the man who spent his career proving that Mercury was hiding something even stranger than a bent orbit? We are only beginning to find out. Here is a contradiction that should not exist. Mercury's daytime surface temperature can reach 430 degrees Celsius, hot enough to melt lead. And yet, in certain permanently shadowed craters near its poles, scientists have confirmed the presence of solid water ice. Ice on the planet closest to the Sun. Let that settle for a moment. The explanation lies in Mercury's nearly upright axis. Unlike Earth, Mercury barely tilts as it orbits, which means certain deep craters near its poles never receive a single ray of direct sunlight. Inside those craters, places like Chao Mengfu near the South Pole, temperatures plunge to nearly minus 170 degrees Celsius. In those permanent pockets of darkness, ancient ice, likely delivered by comets and asteroids over billions of years, has simply never had the chance to melt. Imagine standing at the rim of one of those craters. On one side, heat that would blister and boil. On the other, mere meters away, a cold so absolute it could preserve a human body indefinitely. Mercury does not know moderation. It only knows extremes, pressed together in the same breath, separated by nothing more than a line of shadow. There is something almost cruel in that geometry. Warmth and freezing so intimate, and yet permanently divided. Scientists studying these polar craters describe the isolation of that ice in strange, almost emotional terms. It has waited there, untouched, since before complex life crawled onto Earth's continents. It has never known light. It has never known change. In many ways, it is the loneliest water in the solar system, trapped, frozen, and utterly cut off from everything else Mercury could have been. The silenced cosmologist, in the fragments of writing that still circulate among a handful of researchers, once referred to these polar craters not as scientific curiosities, but as tombs. He believed, according to those notes, that something about their permanent darkness mattered far beyond planetary geology. What did he mean by tombs? The answer connects directly to the strangest discovery Mercury has ever offered us. And it begins in the next chapter. On the surface of Mercury lies a wound. Scientists call it the Caloris Basin, an impact crater over 1,500 kilometers wide, formed billions of years ago when an asteroid struck the planet with a force almost impossible to calculate. It remains one of the largest impact structures in the entire solar system. But the crater itself is not the mystery. What lies on the opposite side of the planet is. Directly across Mercury from the Caloris Basin, on the precise geometric other side of the world, lies a region of jumbled, chaotic terrain unlike anything else on the surface. Scientists call it, appropriately, weird terrain. The leading theory suggests that the seismic shock waves from the Caloris impact traveled through the planet's core, converged with mathematical precision on the far side, and violently shattered the crust from within. A single blow felt on both sides of an entire world. Think about the scale of that event, an impact powerful enough to fracture terrain on the opposite hemisphere of a planet without ever touching it directly. Mercury absorbed a wound so severe that its consequences echoed through solid rock and reassembled themselves thousands of kilometers away. It is the geological equivalent of a scream traveling through ice and shattering glass on the far side of a frozen lake. And here is what makes this more than a curiosity. Mercury is also slowly shrinking. As its massive iron core cools over billions of years, the entire planet contracts, wrinkling its surface into towering cliffs called lobate scarps, some over a kilometer high. Mercury is quite literally collapsing in on itself, 1 degree of cooling at a time. A planet that scarred itself from within and has spent eons since quietly folding inward, like something withdrawing from the world. Researchers close to the silenced cosmologist's earlier work say he obsessed over this detail in particular. The idea of a planet wounded once and permanently changed, still folding inward billions of years later. A planet that shrinks. A wound that echoes across its own body. As we move deeper into Mercury's silence, the mystery is no longer just about geology. It becomes about isolation itself. Every field of science has its outliers. Researchers whose ideas sit just outside the comfortable center of consensus. In Mercury studies, one name surfaces again and again in old conference footnotes and unpublished manuscripts, always incomplete, always mentioned in passing. Colleagues eventually stopped citing him. Then they stopped mentioning him entirely. We know him only through fragments. What we do know is this. He spent nearly 2 decades analyzing data from the Mariner 10 and Messenger missions, the 2 spacecraft that have given humanity almost everything we currently understand about Mercury's surface and magnetic field. Mariner 10 flew past the planet 3 times, in 1974 and 1975, capturing the first close images humanity had ever seen. Messenger later orbited Mercury for 4 years, mapping its entire surface and confirming, among other things, the water ice hidden in its polar shadows. Somewhere within that data, according to those who knew him, the silenced cosmologist began noticing irregularities in Mercury's magnetic field. Small, inconsistent fluctuations that did not match any existing model of how a planet's magnetosphere should behave. Mercury's magnetic field is already strange enough on its own. At barely 1% the strength of Earth's, it should not exist in any significant form at all, given how slowly Mercury rotates. And yet it persists, deflecting solar wind and creating an invisible bubble of protection around a planet that, by conventional physics, should have none. He believed, as far as the surviving notes suggest, that these fluctuations were not random. He described them in one fragment that has survived among former colleagues as behaving less like noise and more like structure, as though something in the planet's core was responding, not merely existing. That single idea, some say, was enough to quietly end his standing in the scientific community. Not because he was proven wrong, because no one would engage with the question at all. We do not know his face. We know only his outline, glimpsed in the edges of old symposium photographs, always turned slightly away from the camera. A man who spent his career listening to a planet everyone else had already stopped listening to. What exactly did he hear in that silence? To answer that, we have to go back to the very thing that makes Mercury's magnetic field possible at all. And it is stranger than anyone expected. Mercury should not have a strong core relative to its size, and yet it does. Dramatically so. Roughly 85% of Mercury's radius is occupied by its iron core, a proportion unmatched by any other planet in the solar system. If Earth had a core this large relative to its body, our own iron center would extend almost to the surface. Mercury is, in essence, mostly hard, wrapped in only the thinnest shell of rock. Scientists still debate why. One leading theory suggests that a colossal impact early in Mercury's formation stripped away much of its outer rocky mantle, leaving the dense metallic core exposed and dominant. Another theory proposes that the young sun's intense heat vaporized Mercury's lighter surface materials before the planet fully solidified. Either way, the result is the same: a small, quiet world with an oversized molten iron heart still churning beneath its silent crust today. This is what generates Mercury's fragile but persistent magnetic field. The slow, internal churn of liquid metal, spinning within a solid outer core, creating the invisible shield that has puzzled researchers for decades. It is not a strong field. It is not even a particularly stable one. But it is there, and it should not be, and it continues to protect this small, overlooked world from the relentless pressure of solar wind, one faint pulse at a time. There is something quietly moving in that image if you allow yourself to sit with it. a planet stripped almost bare, reduced to its molten core, and still, after 4.5 billion years, that core keeps beating, keeps generating a shield no one predicted it could sustain. Mercury does not have an atmosphere to protect it. It does not have a thick mantle to insulate it. It has almost nothing except that improbable, persistent heartbeat at its center. This is where the story turns colder and closer. Because to understand what the silent cosmologist believed he found, you have to understand that Mercury is not simply protecting itself. It is, in a sense, isolated, a world separated from the rest of the solar system by conditions so extreme that almost nothing can survive near it, and almost no one has ever chosen to look closely enough to find out what that isolation might be hiding. From here, the tone of this investigation changes. We move from the mysteries written into Mercury's rock and orbit to the isolation written into its very existence. There is a particular kind of cold that has nothing to do with temperature. It is the cold of complete separation, of existing at a distance so extreme that connection becomes impossible. Mercury lives inside that kind of cold, not because it is far from the sun, but because it is, in almost every meaningful sense, cut off from everything else. Consider what Mercury lacks. It has no meaningful atmosphere, only a thin, fragile exosphere made of atoms knocked loose from its surface by solar radiation and micrometeorite impacts. It has no moons, not one. Of all the rocky planets in our solar system, Mercury alone drifts through its orbit with absolutely no companion, no satellite, nothing circling beside it to share the silence of that journey. Venus, Earth, and Mars all have something. Mercury has nothing but the sun, blazing far too close, and the emptiness stretching endlessly behind it. There is a particular kind of loneliness in that. Imagine an existence defined entirely by proximity to something overwhelming, with nothing else nearby to offer perspective, comparison, or company. Mercury does not orbit in relationship with anything. It orbits in isolation, tethered only to the very force that scorches half its surface and leaves the other half locked in permanent freezing shadow. Like a figure standing too close to a fire for warmth and too far from everyone else for comfort. The temperature swings alone tell part of this story of separation. From 430 degrees Celsius in direct sunlight to nearly minus 180 degrees in shadow. A range of over 600 degrees on a single world, often within the same day. No other planet in our solar system experiences anything close to that violence of contrast. Mercury does not simply endure extremes. It is defined by the impossibility of ever finding a middle ground. It becomes difficult, watching this pattern closely, not to think of the man who once studied it obsessively. A researcher who withdrew from public scientific life, who spoke to fewer and fewer colleagues each year, who chose, in the end, something close to Mercury's own condition. Proximity to a subject that consumed him, and distance from almost everyone else. In the next chapter, we look closer at what isolation like this can do, not just to a planet, but to the people who spend their lives trying to understand it. There is a specific silence that settles over long-term isolation, whether it belongs to a person or a planet. It is not simply the absence of sound, it is the absence of exchange, of anything moving in, anything moving out. Mercury's permanently shadowed craters embody this silence perfectly. No sunlight has entered them in millions of years. No warmth escapes them either. Picture the physical reality of that darkness. In Chao-Meng-Fu crater and others like it near Mercury's poles, the temperature remains locked below minus 170 degrees Celsius, permanently, unceasingly, regardless of what happens on the blazing surface just kilometers away. Scientists studying MESSENGER's radar data found reflective deposits inside these craters consistent with water ice. matter that arrived from comets and asteroids across billions of years and then simply stopped, frozen in place, never released, never touched by light again. There is something worth sitting with in that image, matter that traveled across the solar system, only to become permanently trapped the moment it arrived. It did not evaporate. It did not integrate into anything larger. It simply remained exactly as it fell, inside a darkness with no beginning and no end that anyone alive will witness. Isolation on Mercury is not a temporary condition. It is geological. It is permanent. It becomes, quite literally, written into the landscape. The silence cosmologists' surviving fragments return again and again to this same image. The crater as a kind of frozen archive, holding something intact specifically because it was cut off from everything else. In one note, reportedly recovered by a former research assistant who chose to remain anonymous, he wrote that isolation preserves what connection would eventually erode. Whether he meant this only about ice or about something closer to his own withdrawal from scientific life remains to this day unclear. What is clear is this: the closer researchers looked at Mercury's shadows, the more they found preserved there, untouched, unchanged, sealed away by cold and darkness, so complete that even 4.5 billion years of solar system history could not reach in and disturb it. As we move into the final chapters of this investigation, we return to the man behind the silhouette, and to the very last thing he is known to have said about Mercury before he disappeared from public record entirely. Public records involving the silence cosmologist grow thin after a certain point, then stop almost entirely. Former colleagues describe his final years of active research as increasingly withdrawn. Fewer conference appearances, fewer co-authored papers, longer stretches of silence between correspondence. And then, according to those closest to that period, nothing. No further publications, no further public statements. Only the outline of a man who had spent his life listening to a planet that almost no one else cared to hear. The last documented remarks attributed to him, reportedly delivered during a small, poorly attended seminar, concerned Mercury's peculiar magnetic anomalies, the same fluctuations he had spent years analyzing. He is said to have described them not as errors in measurement, but as evidence of something the scientific community was not yet prepared to seriously consider. He offered no dramatic claim, no sweeping theory, only a quiet insistence that the data deserved more attention than it had received, and a warning that some mysteries resist study not because they are unsolvable, but because almost no one is willing to stay in the cold long enough to solve them. There is real physics beneath this story that grounds it firmly in fact, even as the man himself recedes into rumor. Mercury's magnetic field genuinely does behave asymmetrically, stronger in the northern hemisphere than the southern, a phenomenon confirmed by MESSENGER's orbital data and still not fully explained by planetary scientists today. This asymmetry remains an open question in current Mercury research, discussed cautiously in academic papers, without any definitive consensus on its cause. It is tempting to dismiss the silence cosmologist as simply a case of a researcher who drifted too far from the mainstream and paid the professional price for it. Perhaps that is exactly what happened. Science, after all, is unforgiving toward ideas that arrive before their evidence is complete. But it is worth remembering that Mercury itself once did the same thing to Newton, and it took Einstein's radical reimagining of gravity to finally catch up. Whatever the truth, one fact remains undisputed. He devoted a working life to a subject the world had almost entirely stopped watching, and in the end, the world extended him the same silence he had spent his career studying. From here, the investigation turns inward, away from data and toward what a planet like Mercury might quietly be trying to teach us about time, distance, and the parts of ourselves we rarely examine. There is something Mercury forces us to confront if we allow it to. It is the closest planet to the greatest source of light and warmth in our entire solar system. and yet it remains, in almost every measurable way, the most isolated of the rocky worlds. Proximity, it turns out, is not the same thing as connection. Sometimes the closest thing to us is also the thing that leaves us most exposed, most extreme, most alone. Physics offers a strange kind of comfort here, if you look for it. Einstein's general relativity, the very theory that finally explained Mercury's orbital anomaly, tells us that gravity is not a force reaching across empty space. It is the shape of space itself, bent by mass, guiding every object, planets, light, time, along paths they cannot choose to leave. Mercury does not resist its orbit. It simply follows the curvature it was given, tracing the same tightening path around the Sun for over 4 billion years, unable to do anything except continue. There is a version of that truth that applies well beyond astronomy. Many of us spend long seasons of life orbiting something too bright, too demanding, too close to allow for anything resembling ease, a responsibility, a loss, a role we did not entirely choose. And like Mercury, we sometimes discover that the nearest thing to us casts the longest shadow, leaving entire regions of ourselves that light simply never reaches. Mercury's permanently shadowed craters, holding their ancient, untouched ice, are not failures of the solar system. They are simply the parts of that world that circumstance placed beyond the reach of warmth. There is no judgment written into that condition. It is not something the planet did wrong. It is only where it happened to be, given the shape of the space it was born into. Perhaps that, too, is worth remembering the next time we look at the coldest, most isolated parts of our own lives. The silent cosmologist, in what remains of his writing, seemed to understand this instinctively, long before most of his colleagues did. He studied a planet defined by extremity and isolation, and in doing so, quietly became defined by the same conditions himself. In the final chapters of this documentary, we ask what all of this ultimately means. For Mercury, for the man who studied it in silence, and for anyone watching who has ever felt closer to the fire than to the people beside them. There is an old quiet truth embedded in Mercury's frozen craters, one that physics confirms even as philosophy has long suspected it. Cold preserves what warmth would eventually dissolve. The ice sitting in Mercury's permanent shadows has survived, unchanged, for longer than complex life has existed on Earth, precisely because nothing ever reached in to disturb it. Isolation, in that narrow sense, is also a form of protection. But protection and imprisonment can look remarkably similar from a distance. The same darkness that has kept Mercury's ancient ice intact has also kept it forever separate from everything else the solar system has become. From the light, from the warmth, from the slow churn of change that shaped every other world we know. It has been preserved, yes. It has also never been allowed to become anything more than what it already was 4 billion years ago. This tension sits at the very center of what makes Mercury, quietly, one of the most human planets in our solar system to study. We recognize something of ourselves in that paradox. The parts of us we protect so carefully that we never let them change, grow, or be touched by anyone else again. Sometimes what we call self-preservation is simply a slower, gentler name for isolation. Mercury does not judge which one it is. It simply holds both, permanently in the same frozen ground. Time itself behaves strangely on Mercury, and perhaps that is fitting. A single day there lasts 176 Earth days, while a year takes only 88. On Mercury, more days pass within a single sunrise to sunrise cycle than fit inside 2 entire orbits around the Sun. Time and distance, cause and consequence, all of it arrives out of the order we expect. It is difficult not to hear an echo of mortality in that detail. How briefly and strangely our own sense of time can bend under the right kind of gravity.
We return, one final time, to the silhouette that has followed this documentary from its opening frame. a man who spent a working life listening to a small, cold, overlooked world, and who, in the end, seemed to disappear into the very isolation he spent decades trying to understand.
In our final chapter, we close this investigation, not with a resolved mystery, but with the quiet question Mercury leaves every one of us to sit with. We began this documentary by pointing our attention toward a planet almost no one bothers to look at. A small, scorched, silent world, hiding ice in its shadows and a warped confirmation of gravity itself in its orbit. We end it instead with a question that has very little to do with astronomy at all. What do we choose to preserve by keeping it in the dark? And what might we lose by never letting the light reach it at all? Mercury does not offer easy answers. It offers extremes. Heat and cold pressed together with no gentle transition between them. Isolation and preservation folded into the very same craters. A wounded core still cooling and contracting after 4.5 billion years. Still shaping the surface from somewhere deep inside where no one can see it happen. It is a planet defined less by what it has, and more by everything it has learned to survive without. No moon, no atmosphere, no companion, only the sun, always too close, and the silence, always too complete. The silence cosmologist remains to this day more outline than biography. A silhouette glimpsed at the edge of old photographs, a handful of surviving notes, a career that quietly folded inward the same way Mercury's own crust has folded inward for billions of years. Perhaps he understood something the rest of us are only beginning to consider. That the coldest, most isolated places, whether on a planet or within a person, are not empty. They are simply waiting patiently in the dark for someone willing to look closely enough to notice they were never truly empty at all. If this documentary gave you something to sit with tonight, a new fact about the solar system, a strange kind of comfort, or simply a reason to look up differently the next time Mercury crosses the evening sky, consider staying with us a little longer. Subscribe to this channel so you do not miss the next investigation into the quiet mysteries our solar system has been keeping. If this story reached you in any way, leave a like below. It genuinely helps this kind of careful, patient storytelling find the audience it is made for. And before you go, we would like to hear from you directly. Have you ever felt in your own life something like Mercury's condition, close to the fire and yet strangely alone? Tell us in the comments below. Some of the most meaningful conversations this channel has ever had started exactly there, in that quiet space between one video ending and the next mystery beginning.